going to be looking at example 1 in your section 4.5 notes. For these optimization problems, we're going to have a 3-step process. We're going to find our objective and constraint equations. Then we're going to use those equations to evaluate and find the first derivative and get the information from that. And then we'll find our answer. So for step 1, you want to think about your objective equation as kind of your goal. So for this problem, we want to find two numbers, x and y, satisfying this equation. That's actually our constraint because we're restricted by that. So I'll write that down there. Okay, and our goal is that the product of x and y is as large as possible. So I'm going to use a capital P for product, and then of course that means multiply x and y. Okay, so we need to get our objective equation down to one variable. So easiest way to do that is to use this constraint, and we know that y equals 12 minus 3x, and then we plug that in. Okay, so our product equation is going to be all about x. It's going to be x times the quantity 12 minus 3x, or 12x minus 3x squared. Okay. All right, so definitely you can find the first derivative very easily from there. So taking the first derivative, we get 12 minus 6x. We need to find the critical points, so we set that equal to 0. Okay, solving for that, we get a critical point of x equals 2. We're going to evaluate that on our interval of interest. So if we look back at our product equation, we can see that the smallest product, if we set this equal to 0, would be 0. And then same thing here, setting this equal to 0, we have an interval of 4. Okay, so we'll evaluate over here. From 0 to 4, we have 2 in there. All right, so plugging in a number like 1 into our first derivative, we'd have 12 minus 6, that's a positive number. All right, and if we plug in a number like 3, we're going to get a negative number. So that tells us we are going to get a local maximum. All right, so seeing that from the picture, going increasing and then decreasing. All right, this actually ends up being an absolute maximum because our equation is a parabola, so that's good news for us. So the answer of x equals 2 is what we want for our x coordinate, and it's very, very easy to find our y coordinate. We just need to plug in 2 here. All right, and when we do that, we get 6, and we're finished with example 1.